So the next few lessons and videos can be a little more intense than what you're used to in Comp Sci. Probably today's not too bad. The next video is probably one of the trickier ones that you'll see. So be sure to pay close attention and call me over or make notes if you got questions. Stop right away and don't move on until you get all your questions answered. Okay, so we're doing notes on sorting. And there's a couple types of sorting methods we're going to talk about. Today we're doing one, tomorrow we'll do another. All right, so here's the general task we're trying to accomplish. Our task is we want to sort objects from smallest to largest. Could be numbers, could be actual objects. Most of the time for you, it's going to be numbers. Okay, so that's not a difficult task. There's obviously only one correct answer. But if I watched you sort something from smallest to largest versus the person next to you sort something from smallest to largest, the way they get there, the process they use to get to that one correct answer could be different. So one correct answer, but more than one strategy to get there. All right, and if you were looking through a list of numbers and we're trying to sort it from smallest to largest, there might be different strategies that you take to do it, but whatever you do, your brain looks for something, some way to get it from the smallest on one side, the largest on the other side. So the idea is that the computer has several different algorithms for sorting. And they all have specific names. And like I said, we're only going to talk about a couple this time, or a couple in this class, but you'll see that there are multiple different ways to do it, even more than what we talk about. We've talked a little bit about algorithms in the past. Algorithms are basically just a list of steps that the computer can follow in order to accomplish a task. Okay, so the one we're going to look at today is called selection sort. And what you want to think of when you think of selection sort, if I say it just in a couple words, look for smallest and then swap. Okay, that's the quick 6-word definition of selection sort. More specifically, this is what selection sort does. The computer goes through the array. Because when we're sorting, we're going to be sorting arrays. So everything's kind of contained in one variable. And selects the smallest object. then swaps it with the current object. All right, and that still might seem maybe a little confusing to you. So I'm going to demo a couple examples before we actually write the code here. And in order to help me demo, I've enlisted the help of your old friend, Carol. Okay, so here's an array of Carols, and we want to sort them from smallest to largest. So this is what selection sort does. It's going to go through this entire array. So starting at space 0, going until 9, or array.length, whatever you want to say. It's going to say, okay, currently I'm at space 0. I'm going to say, let's suppose he's the smallest guy. If I find someone smaller than him, are you smaller? Yep. Okay, now I'm the smallest. Are you smaller? No. Are you smaller? Yes. Are you smaller? No, no, no. Oh, yep, found a smaller again. Now he's the smallest. Are you smaller? Yes, no, no. Okay, so the guy at 7 is the smallest. So then it's going to swap. And in order to swap, I'm currently at space 0. This is space 7. I want to save the current guy. So let's save him. He's saved. Space 0 equals the smallest. I didn't want to lose him, so where the smallest was, he's going to go in right there. Okay? That's the first time through, or when I is 0. When I is 1, now we're here. I don't need to check the 0 guy because I know he's the smallest. He's where he needs to be. So starting from here and going to the end of the array, I'm going to look for who the smallest is. Looks like it's 3. So we're going to save and swap. Okay, now these two guys are sorted. Now I'm at space 2. Who's the smallest? Looks like 3. So 3 and 2 are going to flip-flop. Now 0, 1, and 2 are all sorted. And hopefully you can start seeing if I follow through this process, I'm going to get the smallest to largest. Let's just go through just for fun. Smallest is 4, so we'll swap them. Smallest is, I think, 5. So swap these two. Smallest is 6, so now we swap these two. Now the smallest is 8, so I swap 6 with 8. And once I get to 7, he is the smallest, so I don't have to do anything. Technically, he swaps with himself. Same with 8, he swaps with himself. 9 swaps with himself. And now I'm all sorted. And every time at each current spot, I looked for the smallest guy remaining and just swapped him with the current spot. That's an algorithm because that gives me a strategy that I can follow, and the computer, I can write for the computer to follow, that's going to get me to the correct answer in the end. All right? Okay. So hopefully that made a little sense. Let's do a number example. Now the number examples are important because that's really what you're going to be doing in the code. You're going to be looking for a smaller number. And also when we eventually get to a test on sorting, this is a good type of question I can ask on a test. Okay, so let's say my array right now is 2, 3, 5, 1, and 4. And I want to sort that. So after the first pass through in selection sort, it would say the smallest number is 1. So it's going to flip-flop 1 and 2. So 1's going to go here, 2's going to go here, 3, 5, and 4 stay the same. Now the second time through, it's looking for what goes in the second space. So it looks from 3 to the end, the smallest number is 2, it's going to swap 2 and 3. So nothing happens with 1, 2 comes here, 3 comes there, 5 and 4 don't move. Okay, so now these two are already sorted, just like that one was already sorted the first time. And the third time through, I'm looking for what goes in this space. So it looks from 5 to the end. Smallest element's 3. It's going to flip-flop 3 and 5. It's not going to do anything with 1 or 2. 3 and 5 flip-flop, and 4 didn't move. And now after 3 passes, those numbers are all sorted. Okay, fourth time through, we know these are already sorted, so I don't have to worry about those. I'm looking for here, what's the smallest element? It's 4. So 4 and 5 are going to swap. And by default, I just put 4 in the right spot. 5 has to be in the right spot because there's nothing left to compare it to. So after 4 passes through, I figured out what the correct order was. Okay? So that's how selection sort works. If you have any questions up to this point on the process of selection sort, pause the video and call me over. But if you're ready, we need to write the code for selection sort. Now the next program you do is all about sorting. And you're going to have to put the code for selection sort in your next program. I'm going to write it all out for you right now so you can literally just copy the code from the notes into the program. So make sure you're taking complete notes going forward here. Okay, so here we go. Code for selection sort. All right, now rather than just write one giant code that does all of this, let's kind of break it up into steps. We're going to use helper methods. So we need helper methods. And we've kind of been saying the 2 major steps of selection sort are to figure out what the lowest value is. So the first helper method is going to be called find lowest. And once we find the lowest, what do I do with that? I swap it with the current element. So swap is the other method we're going to be using. Now in order to do selection sort, I'm going to kind of put those 2 methods in a method that's just called selection sort. So our overarching method is going to be called public void, because we're not going to be returning anything, selection sort. I do need a parameter because I have to sort a certain array, so I need to give it an array. So I'm just going to give it int bracket bracket a. And I'll even write the pre and post conditions for you because you'll need those in the program also. But the pre condition is just an array of ints, probably unsorted, doesn't have to be. And the post condition is that it uses selection sort to sort smallest to largest. Uses selection sort to sort smallest to largest. Okay, now when this method's done, array A is going to be in a different order. But remember, I can change the value of elements in an array inside a method, and it will be changed wherever you use it in the program. So that's why I don't need to return anything. That's why this is a public void. All right, so the first thing in this method is a variable called int min. And just so you kind of know what I'm thinking, I'm going to say, put a comment off to the side here. What int min does is it holds the position of the smallest element in the array. Holds position of smallest element in array. So I need to know the position where that smallest element is. Not the actual smallest element, it's just holding the position of it. That'll be important later. All right, next we need a for loop because I need to sort the entire array. So my for loop is going to start by sorting the first element. So it's got to, in order to go through the array, I've got to have for int I equals 0. I is less than a dot length, no parentheses on an array, I plus plus. And at each element that it's looking at, it's going to first figure out where the lowest is. So I'm going to set min equal to that find lowest method that I said we're going to need. And find lowest is going to need a couple pieces of information. Now, I remember when I was using Carol to find the smallest guy, let's say if this was my current position, I would search from here to the end. So I need to know what the array is, and I need to know where to search from. I don't want to find the lowest from the beginning if I'm looking for what goes in space 3. I only want to know from here forward. Okay, so find lowest has the array A, and it has I, which is the position I'm currently at in the array. So as a comment here, I'm just going to write, we only want to search from current position in the array. And that's why I have to send it I, because that's where I'm currently at. So start my search from there. Okay, so I set that equal to min, which means find lowest is going to have to be a public int, because it's returning the position of that lowest value. And after I find where the lowest is, I do the other helper method, which is swap. And obviously I need the array A to swap it, but I also need to know what to swap. And I want to swap where I said the min is with the current position, which is I again. Okay, so I'm swapping in the array A, whatever is at position min with position I. And that is the end of the for loop, and that is the end of the selection sort method. So right there, that is selection sort. Now, that's not necessarily the hardest part of writing the code. Find lowest is probably the next hardest part we got to do. So I've got to be able to go through the array from space I to the end, finding the smallest value. Okay, so we've done stuff like that before. So I said this is going to have to be a public int because we're returning the position of the lowest. So public int find lowest. And it's going to need the array to do that. That was our first parameter. Make sure you write the parameters in the correct order. So we have A and I. And I, again, represented the start position. So I'm just going to say int position, POS. And in my precondition, I'll describe what both of those are. We've got an int array. And the starting position. I mean the starting position, where to search from. And our post condition is again that it returns the position of the smallest element. Starting at position. Starting at that POS variable. Okay, now let me run back to Carol for a second to show you how I do this. So I'm going to reset the page to how we started. So initially I wanted to figure out what's the smallest position in order to go in this spot. So initially I've got to just say, okay, let the current spot be the smallest. So initially Smallest is going to be wherever I'm currently at. Okay, so the first thing I'm going to say is I'm going to make something called low, int low. I'm going to set it equal to where I'm currently at, and that's that position variable that we sent over as a parameter. Okay, so as a comment here, I'm just going to write start searching at position. And again, low is holding the position of the smallest. Low is holding position of smallest. Okay, so next, once I have an initial variable that's saying, okay, this is the low spot right now. Now I have to compare that to everything further in the array. So if he's low right now, I've got to start from, this is the first guy I have to look at. So from here, I need to say, are you smaller than what I'm saying the lowest is? If you are smaller, then you're now the lowest. So again, I need to start from the spot directly past him going to the end of the array. So this time my for loop's not going to start at 0, and it's not necessarily going to start at 1 either. It's going to start 1 to the right of wherever I'm currently at. So I'm going to start int I equal to position plus 1. But I am going to go to the end of the array, so I is less than a.length. I plus plus. And at each spot, I've got to look at that spot I'm currently at. So if a bracket, the spot I'm looking at, if that's smaller than what I'm saying is at the spot at the low position, then we have a new low. What should low equal now? Well, if what's in a bracket I is less than what's in a bracket low is not the lowest, a bracket I might be, so set low equal to I. If it's not, just keep going, so no else. And that's going to work. So like now he's the lowest, and it's going to keep searching until it finds someone lower. Now you're the lowest. Once it gets to something that it never finds something lower than, that will be the lowest position, in this case position 7. So once I get through this for loop, whatever ends up in low will be the lowest position. And what do I want to do with that? I want to get it back to that main selection sort method, so I have to return low. All right? Okay. Now, the last method we have to write is swap. So public void swap. If you need to go on to another page, do that. Again, this is a public void because it's not returning anything. It is changing values in the array, but it's not necessarily changing. When I change values in an array, I don't have to return it. It's already changed automatically. Okay, so look back at swap. Swap had 3 parameters: the array, the min position, and the current position. So I'm just going to say int bracket bracket a. And I don't really care which one's the current and which one's the min position. I just need to know that they're 2 integer positions, so int x and int y. I'm going to swap values at. Okay, so my precondition is an int array in 2 positions. And the post condition, it's not none, even though it's a public void. I've tried to harp on that a few times. It's what the method does. So the post condition is that it swaps the elements at positions x and y. Okay. So again, let's go back to Carol and look what happens. If I want to put the smallest in space 0 and I want to swap them, what I'm first going to do is I'm going to save what's in position 0. So the first thing I'm going to do is say int temp equals a bracket x. I think I said save position 0, but the smallest position, so it doesn't really matter which one I save. But if I save this one, then I need to set that space equal to the current position. So that's going to be done by saying a bracket x equals a bracket y. And then finally, what was in the other space should be the temp variable. So we're going to say, to end this up, a bracket y equals temp. And I don't need to return anything. Like we said, it's a public void. Those values will be changed in the original method. And that completes all the code we need for selection sort. Okay, so again, if you have any questions on that code that we just wrote, please ask me. That's going to be super important in your next program, and also super important for the next test coming up. So make sure you really understand this code, and if you don't, please ask me. All right, in the next video, we'll look at another type of sorting algorithm called insertion sort. But that's all there is till then. See you later.